All right, everyone, welcome to video number 3 for the test number 2 review packet. Let's take a look at 16a and b to start. So even though, again, it looks complicated, what we really have is a fraction equaling a fraction, and same thing with part b, a fraction equaling a fraction. Some of you might remember in class what I did was I wrote a fraction on the board like 2/3. Then I asked somebody, what is a fraction that's equivalent or equal to 2/3? And I remember somebody said 4/6, which is just double. And then we looked at that if two fractions are equal, that this diagonal, if the 4 and 3 are multiplied, gives me a 12. Then if I look at this diagonal, the 6 and 2 multiplied also gives me a 12. So if two fractions are equal to each other, that means the diagonals, when multiplied, are also equal to each other. And so if I wanted to generalize to something like part A, I don't know what x is, but I do know that 7 times x plus 1 is going to be equal to this diagonal, which is 6 times 42. If I simplify this a little bit and distribute over here, I'd have 7x plus 7 is equal to 6 times 42, which is 252. If I then subtract 7 from both sides, we'd have 7x equals 245. If I then divided by 7, I would get x is exactly 35. And what you could do is, if you're not sure this is correct, you could always plug 35 back in here. So you'd have 6/7. Is that the same as 35 plus 1 over 42? And 35 plus 1 over 42 is 36 over 42. And if I take, let's see, a 6 out of both of these, 36 divided by 6 is 6, 42 divided by 6 is 7, which is equivalent to 6/7. So plugging back in is always a good idea. For part B, again, these fractions look more complicated, but I do know that if two fractions are equal, that this first diagonal when multiplied is equal to this second diagonal when these are multiplied. So that would be 5 times 2x minus 3 is equivalent to 4 times 2x plus 6. So if I distribute on both sides, we'd have 10x minus 15 equals 8x plus 24. I'm going to subtract the 8x over. 2x minus 15 equals 24. Add the 15. 2x equals 39. So if I divide by 2, again, my answer is not perfect, but 39 divided by 2 isn't too bad. You get positive 19.5. So just to remind everybody, these two problems, something like this, were some of the most missed on the first test. Same with number 16, the cross multiplication. A lot of people got it, but I want to keep throwing it out there for review. Same with number 17, part A and B. We did have a lot of students get it, but I thought it was missed enough to put it again on this upcoming test. And I'll remind everyone that of and is always mean the same thing. Of always means multiply, and is equals. So if I wanted to create these both into equations, I have to remember a few things. I have to remember what these mean, and I also have to remember that 15% as a regular number needs to be changed. So remember that the 15, the decimal is originally right here, and if you take the percent off, the decimal moves twice to the left. So this is really 0.15 of times what x is equals 24. And my goal for this is to get x alone. So if I need to remove the 0.15, it's being multiplied. So I divide both sides by 0.15. If I take 24 divided by 0.15, I get 160. Part B, 18 equals what percent, x percent, of or times 150. So if I want to get the x percent alone, I would need to divide both sides by 150. And if I do that, I would get this to be 0.12 equals x percent. Remember, I'm asking what percent. 0.2 is not a percent. It isn't 1 until we move the decimal over 2 times to the right. So my answer is 12%. (18a) and b and 19a and b are all equations with fractions. I did feel that these were, again, more missed than others on the last test. So for part A, my goal is to get x alone. And because 5/9 is multiplying this, we could divide both sides by 5/9, but as we've discussed, this is not very helpful. So instead of dividing by 5/9, we multiply both sides by the reciprocal. So this is a situation that the reciprocal is used. So the 9s and 5s we cross out. So you have x equals negative 20 over 1 times 9 over 5. Negative 20 times 9 is negative 180. 1 times 5 is 5. Negative 180 divided by 5 is a negative 36. So my answer is negative 36 for part A. In part B, my goal is to get A alone. So the 1 is not attached. So I'm going to move that to the other side first. I have A over 2 equals 11. Now on the test, I noticed that some of you did multiply by 2 first. We can't do that yet because we need to move the least attached thing to A to start. We are not done yet because A is being divided by 2. So the inverse is to multiply by 2. So you'd have A equals a positive 22 is my final answer. And just like the cross multiplication problems, remember, you could always take this answer and plug it back in to see if you're correct. So if you think that A is 22, you could always plug it back in and see if both ties are true. You're asking yourself, is 22 divided by 2, which is 11, minus 1, is that equal to 10? And because it is, I know this answer is right. 19 part A, again, I picked another fraction problem because I noticed some got it and some didn't. If I want to get x alone, notice that the 2/5 is being added to x. So unlike 18a, where we could use the reciprocal, here we're not multiplying or dividing. What we need to do to get 2/5 to the other side is subtract. So x then is equal to negative 7/4 minus 2/5. And this is a situation where we need a common denominator because we're adding or subtracting. And so this fraction, the common denominator is going to be 20, so it needs the 4 over 4. And this fraction has the 4, so it needs the 5 over 5. So if I simplified this a little bit, this would become negative 35/20 minus 8/20. Remember, the denominator never changes, just the numerator. So negative 35 minus 8 would get me a negative 43/20. Part B, we have a giant fraction to start, and as we talked about in class, if we have a giant fraction, we want to get rid of the problem. So we'd multiply both sides by 5. 2y minus 4 would be equal to negative 8 times 5, or negative 40. We would then continue to get y alone by adding 4 on both sides. So 2y is equal to negative 36. We would divide both sides by 2 and get my final answer to be y equals negative 18. Last but not least, number 20. Write an equation and solve. This one, again, was one that was missed on the Chapter 1 test or something similar to it. So we have 2 less than 4 times a number is equals negative 16. So when you see 4 less than, I know because we've been doing inequalities, it's tempting to say that this represents an inequality, but less than, remember, could also mean subtraction. So if we're thinking 2 less than 4 times a number, first, 4 times the number x could just be represented as 4x. Then if you have 2 less than this multiplication, that could be represented as 4x minus 2 equals negative 16. So this would be your equation. And if you wanted to solve it, we would add 2 to both sides. 4x equals negative 14. So yes, again, I do have you getting a decimal here. Negative 14 divided by 4 is a negative 3.5. I would say the most common mistake I saw on the test was this. A lot of people had 2 minus 4x equals negative 16. The reason this is not correct is because when it says 2 less than, that means that the multiplication came first and then we subtracted 2, rather than subtracting the multiplication from the 2. So if you got this incorrect on the test, please just be careful of that on the upcoming second test. All right, guys, that's the end of the videos. Again, feel free to go back and rewatch anything you need. Feel free to come in for help. Email either myself or Mr. Foster if you need anything. All right, thanks, guys. Good luck studying.